everyone. The Coordinating Center for the National Drug Early Warning System, sponsored by the National Institute on Drug Abuse, is pleased to welcome you to our March NDUS Presents webinar. The NDUS PI is Dr. Eric Wish, and our NIDA project scientist is Moira O'Brien. I believe that both of them are in the audience with us this afternoon. My name is Erin Artigiani, the NDUS COI. Barbara Kerr, Marwa Al-Nasir, and I will be the facilitators for this webinar. We are part of the NDUS Coordinating Center team based at the Center for Substance Abuse Research at the University of Maryland in College Park. For those who are interested, you can find detailed information about NDUS, recordings of prior webinars, and invitations to future webinars on our website at www.ndus.org. You will also find instructions for how to join our NDUS network and participate in ongoing discussions with nearly 1,400 experts and concerned citizens from across the United States and many other countries. So we hope we will see you there as well. We developed the NDUS Presents webinars to work with leading substance abuse experts to explore emerging drugs and timely drug-related topics. This month, we are excited to be joined once again by Jill Head, Supervisory Chemist at the U.S. DEA's Special Testing and Research Laboratory. As you may recall, Jill helped us launch the NDUS Presents webinar series in February 2016. Since then, we have been fortunate to have the opportunity to release the quarterly and annual emerging threat reports produced by her lab through NDUS, and you can find them all on our website. Today, Ms. Head will provide information about seized drug compositions and mixtures containing fentanyl and a brief update on emerging synthetic drug threats in the United States. Her comments are based on data from the forthcoming 2018 annual report, which is currently in process, and we hope to release it later this month. It will be made available on the NDUS website, which again is www.ndus.org, along with all the other reports that we have released. So keep an eye out. I'll also make an announcement on the network about it, so keep an eye out for that as well, and our announcements about future webinars. This webinar will be approximately 60 to 90 minutes long, and we encourage you to submit questions during and after the presentation. Please do not raise your hand. Instead, we ask that you please post your questions in the Q&A box, and we will hold a Q&A session after the presentation. Ms. Head, Barbara, Marwa, and I will do our best to get to all of your questions, but I'm sure there will be many, and we will try to address any remaining questions after the webinar. A recording of this webinar and a copy of Ms. Head's slides will be made available on our website, which once again is www.ndus.org. So thank you for joining us, and we hope that you enjoy this webinar. Jill, I'll turn it over to you.
Thank you, Erin and Eric and Moira and everyone there at NDUS. It's great to be able to come back each year and provide an update on synthetic drug threats in the United States. And I am glad to be presenting our update, our 2019 update, which is going to be based on drug seizures in 2018. So over the course of this presentation, I'm going to provide a very short overview of our DEA Emerging Trends and Reference Materials program. I will present the data that we compiled for the Emerging Threat Report that covers several synthetic and NPS drug classes. So we will discuss synthetic cannabinoids, synthetic cathinones, fentanyl, fentanyl-related compounds, and new synthetic opioids, as well as some additional information about other NPS classes that we are tracking. And then finally, I'm going to present some data on seized drug composition and mixtures containing fentanyl that have been analyzed by our laboratory system. The Emerging Trends and Reference Materials programs are programs that we have here at the DEA Special Testing and Research Laboratory, where we primarily analyze domestic as well as foreign drug seizures. But the majority of work that we do in this program is on NPS. So in addition to analysis, we also conduct research and method development for the identification and quantitation of NPS as well as other emerging or interesting substances. And these programs also provide reference materials to each of the DEA forensic laboratories, and then also provide reference materials to, on occasion, state and local and other federal as well as international forensic laboratories. When reference materials are not available for forensic drug analysis, our chemists here perform a process called structural elucidation, where based on the data, we can identify unknown or previously unidentified drugs. These groups also author the SWIG drug monographs, which is analytical data that we make available to the forensic community. And at the very end of the presentation, I'll give a very brief update about that and where you can find that data. And a lot of the work that we do in these programs is to monitor past and current trends, to track trends in NPS as well as other controlled substances and drugs of interest, as well as to predict future needs, needs for methods, needs for reference materials, and then we publish the emerging threat report as well. NPS are, we can think this is a definition that we typically use as describing what an NPS is: a new narcotic or psychotropic drug in pure form or in preparation that is not controlled, but which may pose a public health threat. So these are just some of the classes that we track as NPS and that we consider to be emerging threats: synthetic cannabinoids, the cathinones, hallucinogens, synthetic opioids, which we also include fentanyl in that class, benzodiazepines, and other plant-derived highs. This presentation is going to focus primarily on the cannabinoids, the cathinones, and the synthetic opioids. Before I begin to present the data and what it is that we are identifying, I just wanted to clarify what it is that in our laboratory system, what it is that we are analyzing. We're analyzing the seized drug sample. So these are the powders or the liquids or the tablets or the vials that contain the parent drug or the seized drug material. We do not analyze biological samples or toxicological samples, and so therefore we are not identifying metabolites. So as we go through, this data is on the seized drug or parent drug material. The data is acquired through our Laboratory Information Management System, or our LIMS system, which is an electronic database storing the analytical results from the DEA laboratory system. And the purpose of the threat report, of the emerging threat report, is to be able to provide a timely mechanism for tracking what drugs are being seized and identified in the United States in a short amount of time. We're a little bit later in publishing this as usual because we were affected by the furlough earlier this year. But the data that we are presenting covers drugs that were seized between January 1st, 2018 and December 31st, 2018 that were all analyzed by the December 31st of 2018. So they were seized and analyzed within that time period. There are a few considerations when looking at this data. One is the backlog of evidence waiting to be analyzed across the system. And depending on how large a particular laboratory's backlog is, or how many samples have been able to be analyzed, that could affect the number of samples that are reported in this report. In addition to that, the availability of reference materials is really critical for being able to make an identification. So if reference materials are readily available, then those identifications could be made more quickly compared to when a material either has to be synthesized or purchased or just is not available at all. And then finally, the data excludes any analysis performed at our laboratory because typically the work done here is for research or for another special type program or development. I'm going to start by presenting the data for the synthetic cannabinoids that were seized and identified by DEA between January 1st and December 31st of 2018. In calendar year 2018, there were 526 synthetic cannabinoid identifications, which is approximately a 43% decrease in the number of synthetic cannabinoids from the previous year. In 2018, there were 25 different synthetic cannabinoids identified, which is an increase from the 21 identified in 2017. 5-fluoro-MDMB Pinaca and FUB-AMB were the most reported synthetic cannabinoids and accounted for approximately 64% of the identifications during the reporting period. Our laboratories identified 5 new synthetic cannabinoids this period that were seized in 2018. They're marked here by a purple circle, and they're 5-fluoro-MDMB Pica, MMB Chimica, 4-cyanochemobutanaca, MMB 2201, 5-chloro-AKB48. There were additionally 2 others that were reported for the first time, 5-fluoro-EDMB Pinaca and MMB Fubica, but these were not seized in 2018. They were seized prior to that. But it was the first time that they were identified. Moving on to synthetic cathinones. These are the synthetic cathinones that were seized in the same time period. There were 327 synthetic cathinone identifications. And there were just a few more in 2017. There were 369 cathinone identifications in 2017. N-ethylpentylone continues to be the most reported cathinone, accounting for approximately 62% of the identifications during this reporting period. Of the 22 substances identified, 4 were seized and identified for the first time in 2018. But N-ethylhexadrone was also reported for the first time in 2018, but it was seized prior to January 1st. So in total, there were 5 cathinones identified for the first time in 2018. So most of the content of this presentation is going to be based on fentanyl and synthetic opioids. And before I move into the seizures and identifications, that I'd start by just describing the difference between the fentanyl that we're encountering in the United States now compared with pharmaceutical fentanyl. Fentanyl is a prescription drug with legitimate medical use, which is obviously different from most of the NPS. So pharmaceutical fentanyl can be prescribed as lozenges or transdermal patches, sprays, and tablets. But the fentanyl that we are identifying in seized drug samples are a white powder, just like any other illicit substance that we identify in our laboratories. And the challenging thing about white powders is most drugs look like white powders. So it's difficult to be able to tell whether a material is or a substance is fentanyl, like in the bottom right corner, uranyl fentanyl, like in the top left corner, valeryl fentanyl. And we're also identifying fentanyl and other synthetic opioids or fentanyl-related substances in counterfeit pharmaceutical tablets, like the acetylfentanyl pictured in the top right corner. These powdered materials also typically packaged, like many other illicit drugs of abuse, in foil bags, in glassine envelopes. And in addition, in large quantities, we're also identifying fentanyl in kilo, half kilo, and kilo-sized bricks. These are some images of tablets that have been shared with us that are of fentanyl and other substances in counterfeit or mimic tablets. And you'll recognize them, a couple of them, as oxycodone or oxycodone containing preparations. But instead of containing oxycodone, they contained fentanyl or acetylfentanyl. And one of these is particularly interesting to me in the AB Fubinaca, etizolam, and fentanyl tablets, which is a pretty unique combination. Fentanyl can also be seized, well, or abused and used in other methods. The left side are fentanyl nasal sprays, and the center is what is consistent with the appearance of black tar heroin, but actually was found to contain fentanyl. And then in the right side, these are they are blotter paper. Instead of containing LSD or a Nobomi, which we frequently encounter, these were dosed with acetylfentanyl. In 2015, we really started to see the emergence of synthetic opioids as an NPS class. And at that time, there were about 5 synthetic opioids. These were valorolfentanyl, beta-hydroxythiophentanyl, butyrolfentanyl, and acetylfentanyl. And the most identified, of course, would be fentanyl. So this is from 2015. And these substances really differed primarily in one part of the molecule. And I want to try to explain this in sort of simple terms. And I'm going to move my cursor to the region. But in the left-hand side of these molecules, only this chain, we call this a chain, only this chain varies. And these were, this is indicative of what we were encountering in 2015. But in 2016, we saw a large increase in the number of fentanyl-related substances. There were 15 different substances seized and identified in 2016, with about 60% of them reported for the first time. But instead of the molecule being changed or constructed differently in only one part of the molecule, now we're starting to see substitution of other groups in various parts of the molecule. So there's a fluorine added here, and this is the structure of carfentanil, so it differs here. So instead of the molecules differing only in one portion, we're now seeing substitution on each of the ring systems and parts of the molecule, other parts of the molecule. And in 2018, that scenario is continuing. In fact, in 2018, there were 3,591 identifications of fentanyl, fentanyl-related compounds, and other new synthetic opioids. This is approximately 27% increase from 2017. Fentanyl accounted for approximately 76% of these identifications. The next most prominent substance was 4-ANPP, which accounted for approximately 6% of the identifications. And 4-ANPP is an immediate precursor chemical to fentanyl. There were 26 different substances seized and identified for the first time in 2018. And again, these are marked with a purple circle. They're parafluorobutyrylfentanyl, orthomethylacetylfentanyl, 4'-methylacetylfentanyl, N-methylnorfentanyl, isopropyl U47700, despropenyl parafluorofentanyl, and 2-furanylbenzylfentanyl. And then benzoyl fentanyl was also identified for the first time in 2018, but it had been seized prior to January 1st. So this is a very large increase in the number of new synthetic opioids that emerged in 2018. Just briefly about some of the other drug classes, we do in our threat report publish data on hallucinogen identification, benzodiazepines, piperazines, and then other NPS or unusual seizures that don't really fall in any classes. Hallucinogens have virtually remained the same. We haven't identified any new hallucinogens in that class for several years. And this is same is true for piperazines. But the NPS benzodiazepine class is an interesting one. There were flualprazolam was identified for the first time in calendar year 2018, and there were 2 instances of identification. But atizolam was by far the most seized and identified. In addition to that, 2-fluorodeschloroketamine was identified for the first time as well. I wanted to also point out that there were 92 instances of an unconfirmed substance during this reporting period, which is an approximately 74% increase from calendar year 2017. What I'd like to do is move from the data in terms of number of identifications and try to drill down a little bit into what the composition of those samples actually looked like when the sample contained fentanyl. So this data was acquired from exhibits analyzed by our laboratory system, and we compiled this data by searching for identifications of fentanyl and tabulating what that fentanyl was identified in combination with. Oftentimes, fentanyl is not found in combination with any other controlled substances. It might be cut with sugars or any caffeine, acetaminophen, other non-controlled or non-active substances. But here, I wanted to look specifically at fentanyl found in combination with heroin, with cocaine, and with methamphetamine. So the data set that we looked at, there were 4,228 identifications of fentanyl found in combination with heroin, 412 found in combination with cocaine, and 208 found in combination with methamphetamine. And to clarify, each identification was made in the same seized material. So even if there was a seizure that contained multiple bags, these identifications would have been of the same seizure. And it also is, these mixtures may have also contained other substances, either another controlled substance or another non-controlled substance. So over the next few slides, I'm going to show some examples of what these look like. In the first row, this is an example of fentanyl found in combination with heroin from the South Central region of the United States. And this was a large seizure, 7.9 kilograms of powder that were seized. And these were the only 2 substances that were reported. When there isn't any purity data available, it's difficult to say what percentage of that seizure was fentanyl and which percentage was heroin. But there is some of that data available that I wanted to present this afternoon. This is another seizure in the South Central region that was only 6.9 grams, but the heroin was at 2.5%. Similarly, in the Mid-Atlantic region, a smaller type seizure of just under 2 grams that contained 5.4% heroin and 4.5% fentanyl. And then, you can see as you look through this table that throughout the United States, in each of these regions, there can be combinations of heroin and fentanyl only that have been identified by our lab system at varying purities. In the next row, I just wanted to highlight a seizure from the North Central region that was heroin and fentanyl with reported purities of 21 and 2% respectively, and also diphenhydramine was identified in that mixture. And here's one that was a larger seizure, about half a kilogram, that was identified in the northeastern region of the United States that contained heroin, fentanyl, and procaine. And some of the question has been, are large seizures are large seizures more significant, less significantly adulterated than smaller seizures? So I just wanted to point out two seizures from the northeastern region, one that was half a gram that contained heroin, fentanyl, and tramadol, and one that was almost a kilogram that was more adulterated and cut than the half a gram sample. And that one was found to contain heroin at just under 4%, in addition to fentanyl, tramadol, and some additional adulterants. There were several fentanyl mixtures containing cocaine throughout the United States as well, and I decided to just highlight a few of those. There was one in the southeastern region of the United States that contained fentanyl and cocaine, but it was a relatively small seizure at under a gram. A lot of the seizures and analysis that we identified in our laboratories that contained multiple controlled substances with fentanyl were on paraphernalia, like pipes or scales. This is one that contained heroin, fentanyl, and cocaine, but it was a sample on a residue. It was a residue on paraphernalia. But there are some more significant seizures, like this one from the southeastern region that was 4.6 grams. And this sample here was identified to contain cocaine hydrochloride, fentanyl, and phenacetin, and it was about 2 kilograms of powder. But again, it's difficult to say, well, really impossible to say with these results how much of those 2 kilograms were fentanyl, but it was identified in that mixture because we don't have any purity results. And then finally, I looked at methamphetamine and fentanyl mixtures. The first sample was, and you can see most of these are small, and the same is true with the methamphetamine. The majority of fentanyl mixtures with methamphetamine that I reviewed were small quantities or residue samples. This first one was 3.3 grams of powder from the north central region that contained heroin, fentanyl, methamphetamine, and various other adulterants. This is an example of a residue that contained fentanyl, cocaine, methamphetamine, but again, it's a residue, so it could have been from, over time, not necessarily measurable amounts of powder. And then in the southwestern region of the United States, there was over a half kilogram of powder identified to contain 4.6% fentanyl, in addition to tramadol, ketamine, and methamphetamine. And then finally, in the northeastern region, there were tablets that were had been pressed and identified by the laboratory to contain about 0.8% fentanyl, heroin, and methamphetamine. So as you can see from looking at mixtures of fentanyl with heroin, fentanyl with cocaine, and fentanyl with methamphetamine, it really varies widely in terms of drug seizure size and what was identified in that mixture. And these are just a couple of examples of some really complex mixtures that aren't necessarily on the order of kilograms, but they're also not too small either. The first one contained cocaine, heroin, 2-furanyl-fentanyl, which is another fentanyl-related substance, and fentanyl. And then this middle example contains fentanyl, heroin, a synthetic cannabinoid, and another fentanyl-related substance. Excuse me. And then the final example contained 1.5% heroin, a synthetic cathinone, a synthetic opioid, another fentanyl-related substance, in addition to a etizolam, which is an NPS benzodiazepine. This was 49 grams of powder that was identified from our North Central region. The NDUS network has been a tremendous resource for us here in our laboratory, and there's been a tremendous amount of discussion in areas that are really important in NPS and emerging threats to the United States. And last week, there was quite a bit of discussion and concern about marijuana being mixed or laced with fentanyl. So we looked at the data from our LIMS system to determine if it's something that we've encountered here in our laboratories. And we did find a few instances where THC and fentanyl were identified in the same sample. However, the majority of these, about half of them, were residue, meaning that it was a scale or paraphernalia where we would expect to find mixtures of substances. But when we looked at the description of those samples, none of them were identified as plant material. They were all either identified as mostly powder or residue. So based on the data set that we reviewed, we didn't find any indication of marijuana and fentanyl being identified in our laboratory system. That's not to say that it has not happened, but we did not find any indication of marijuana laced with fentanyl based on exhibits that we analyzed in our DEA lab system. With all of the new NPS, we do continue to provide reference data and libraries for forensic scientists and for scientists that are making identifications. All of the data that we make available is posted on swigdrug.org. And there are two searchable libraries. There is a GCMS searchable library that was last updated January 31st, 2019, and then an IR library that's available in multiple versions that was updated on February 8th. We also are regularly updating drug monographs to keep those up to date of new reference materials data that we now have available. So in summary, in 2018, 22 NPS were identified for the first time, which equates to about one new substance approximately every 2.5 weeks. And each of the classes of NPS that we track had a new substance that was identified for the first time, with the exception of hallucinogens and piperazine. Approximately 33% of the synthetic opioids identified were seized and identified for the first time in 2018. So this is a class that continues to see a lot of new substances emerge. And finally, seized drug analysis can really be a useful tool. There's been a lot of question regarding, throughout the network, regarding polydrug use and whether or not an individual has taken multiple drugs over a period of time or within the same day, or if the sample itself was a mixture. And so I believe that seized drug analysis really can be a useful tool in understanding these complex mixtures and their relationship to toxicological or medical examiner results. I'd like to thank everyone that's listening for for listening today. I also want to thank a few people here, specifically Emily Lockhart is a senior forensic chemist in our laboratory, and she compiled this data for the presentation and for the emerging threat report, as well as the chemists in the emerging trends and reference materials programs. I just want to thank them for their help in putting this together. And again, thank you, Erin and Eric and Moira for having me back this year. Thank you.
All right, well, thank you so much, Jill. That was really a fantastic presentation, and we appreciate you taking the time, you and your colleagues, to put the slides together for us and to be continuing to produce those emerging threats reports. And again, just to let everyone know, because I know we got a few questions about this, we will post a recording of this webinar and a copy of the slides from the presentation today on the NDUS website, www.ndus.org. You should be able to find the slides by the end of today and the recording by the end of the week if all goes well. So I hope you will take a look at that. And while you're there looking over the slides again, you might also want to visit a new page that we just launched where we have provided links to data for all 50 states and the District of Columbia. And what you'll find there is links to interactive data dashboards and also published reports coming out from all of the states. So that should be of use to you as well. And I know that you've all had a number of questions, and so I want to make sure that we get to the Q&A so that we can start addressing those questions with Jill. So Jill, if you want to pull up the Q&A box, you can run through the questions whenever you're ready.
Thank you, Erin. Sure. So the first question is, it should be clarified that 5-fluoro-MDMB Pinaka is also 5-fluoro-ADB, which may be the way people have reported it previously. That's a good point, and something that is really a little bit complicated in general in making sure that we're all calling a substance the same thing consistently. And yes, that is true. And there may be a couple of instances in the data where it may be a substance that was that can be called something else. For example, some of the fentanyls, like Valoryl and pentanoyl fentanyl, would be the same thing. So thank you. How similar are these seizure numbers to NIFLS and their annual reports? So this data is separate from NIFLS. NIFLS contains state, local, and federal drug seizure data, and NIFLS data actually contains our DEA data, but our emerging threat report data does not contain all the data that's in NIFLS. So our data set is much smaller, and it is only substances that were seized and identified by the DEA laboratory system. The next question is, what about ortho-desmethyltramadol? There are other substances that have been identified in the United States that may be considered an NPS. We typically provide data on particular drug classes. It's also possible that even though this is a substance that had been identified, that it may not have fallen within the window for what we were reporting. The next question is, were the 92 unknown substances all the same substances or multiple substances? These 92 substances would be, it's possible that they are the same substance. The laboratories have a mechanism to be able to report substance unconfirmed when we're not able to make an identification. And there are several reasons we might not be able to make an identification. One might be available reference material. One might be that it needs structural elucidation, or that it has to do with the matrix. For whatever reason, it could not be confirmed. So it's possible that some of the 92 unknown substances were the same. The next question is, atizolame was the largest of the benzos, but do you see the more common ones such as alprazolam, lorazepam, and clonazepam, or are they not considered NPS? We don't consider those NPS because those are legitimate pharmaceutical preparations. For ones that are that fall more within the NPS class, such as they don't have medicinal use or they're not prescribed, and they follow this same sort of umbrella pattern of other NPS, and that would be why we don't include them here. But we do have significant pharmaceutical identifications happening in the lab system. For the drug mixtures containing fentanyl, how were these tested? For example, fentanyl test strips. So the samples that are identified in our laboratory use various analytical techniques. We include techniques such as gas chromatography, mass spectrometry, liquid chromatography, infrared spectroscopy. Test strips are something that that we are not currently using that we don't use for identification in the laboratory. We use analytical instrumentation. Is the tramadol from a clandestine laboratory as well? The tramadol that we are encountering, I can't say whether or not it's clandestinely manufactured. But what we can say is that tramadol is being identified in drug substances that are clandestinely manufactured. But I can't say whether or not they are from a clandestine laboratory. For the speaker, is the fact that opioids are contaminating other substances like cocaine and meth a new phenomenon? I feel like I hear about this more now than ever and have patients who are overdosing on their cocaine. It is the fact that drugs are cut and adulterated is not a new phenomenon. We, for decades, are identifying drugs and all of the other substances that are found in combination with them. Particularly heroin has been adulterated with numerous other substances. I think what is a little bit different now is that fentanyl is really being found in combination with many other drug substances. So by itself with heroin, on occasion with cocaine and with methamphetamine, and then with other fentanyl-related substances. And many of these samples that are submitted to the laboratory for analysis are suspected to contain cocaine or heroin. And in fact, it is after analysis is found to contain fentanyl or some combination. So I feel like this is maybe more frequent now as fentanyl becomes more and more sort of ingrained into all of the other drug samples. The question was, where was the marijuana laced with fentanyl located? And just to reiterate, we did not find any evidence or we did not have any data to support an identification of that mixture. So we have not found marijuana laced with fentanyl through DEA seizures and analysis. Any cases of vape cartridges containing fentanyl and/or THC in fentanyl? I am not aware of vape cartridges containing fentanyl, but I am aware of, obviously, vape cartridges containing THC, as well as vape cartridges containing NPS. But the THC and fentanyl samples that we identified in the system were primarily either residue or powder. I do not believe there were any that were liquids that could be used for vape cartridge. Can we get further information on synthetic drug trends, like the toxicology information? Really, the NDUS network is a great place to get toxicology information. And since we are forensic chemists, we do not have toxicology information, but NIFLS and NDUS are great resources for that information. Why is the diversity of fentanyl analogs increasing? That's an interesting question, and it has to do with the synthesis of fentanyl. In 2015, 4-AMPP was primarily the precursor. It's an immediate precursor to fentanyl. But there are other precursor chemicals that can be used to manufacture it, including NPP. And so what happens is these precursors can be modified prior to being going through the chemical synthesis reaction. And then there can be various other chemicals or acid chlorides that can be used to complete the reaction. So it's a combination of chemicals that can be used to synthesize fentanyl, but also, and I think it's important to see the parallels between fentanyl and fentanyl-related substances and other NPS. The other NPS classes like cannabinoids and cathinones have seen that same pattern now for 10 years. You can believe it's been over 10 years. And fentanyl is following that same pattern of substitution on the molecule. And so it's a combination of following a pattern of NPS and also varying the precursors and precursor chemicals that are being used to manufacture the fentanyl. Do you see a trend in the number of unknown substances found in seized drugs? 92 in 2018, how does this compare to previous years? Also, how does say in the last 3 or 4 years? Also, how many previously unknown substances do we now have identification for? How has this number grown over the same time frame? I'm going to do my best to answer each of those parts of the question. We had seen actually from about 4 years ago, we had seen a decrease in the number of unknown identifications or unknown substances or unconfirmed substances. Part of this has to do with a real serious effort to consolidate all the information that we had available here in the laboratory and to create a program here, the reference materials program, to really focus on acquiring the newest drug standards that are available and elucidating unknown substances to be able to make an identification. And those efforts really paid off, and we did see a decrease in the number of unknown substances. Also, as chemists become familiar with the substances and libraries are created and data is analyzed, we do see that number decrease. But a large part of that has to do with availability of reference materials. The vendors, the reference materials companies that manufacture and sell reference materials have really also been staying up to date and have a lot more substances much more quickly available and readily available for purchase. So all of those things led to a decrease. It's hard to say why in 2018 we saw such a large increase in that number, and I'm sure we're going to be taking a look at that in this year to then go back to that data and see what some of those substances were. And then how many previously unknown substances do we now have identifications for? We do go back and when a standard is available and we are able to go back and make the identification, then we will. It's not always possible, but we do, and we do kind of track that a little bit here to find out when substances were previously unconfirmed, whether or not a standard was available and an identification could be made. And how has this number grown over the same time frame? I think you're referring to standards or how many previously unknown substances we now know, and has that increased or decreased? I don't really have data on that, but I do know that we have, we've identified over 300, probably close to 400 new drugs in the United States since 2010. And that number just continues to increase. But all of the data that we acquired during the authentication of our reference materials, we publish that as libraries, searchable libraries, and also in SWIG drug monographs. And we published, I want to say it's over 200 or 300 drug monographs on SWIG Drug's website.
All right, well, thank you very much, Jill. Again, we really appreciate you and your colleagues putting together such a great presentation and taking the time to wade through all these questions as well. And so I just want to make sure people are aware of our upcoming webinars. We actually have a two-part series on illicit stimulants coming up. And so first we'll be hosting a panel of experts from around the country who will be discussing historical and current patterns of methamphetamine use in the United States and end-use sites. And so we are pleased to say that we will be joined by Jim Hall and Dr. Jane Maxwell from the University of Texas at Austin, and Dr. Brian Dew and Dr. Lynn Brecht from UCLA for that one. And that's coming up on March 25th at 3:30 p.m. Eastern. So keep an eye out for our announcement coming up and get registered for that one. And then in April, we'll be having a similar discussion on cocaine, and Jim Hall will join us again for that one to give us a historical overview of trends through the 20th century. And then we will also be joined by Dr. Marcella Sorg from the University of Maine and Dr. Denise Paone, who are two of our end-use SCEs. And they'll be talking about Maine and New York City, respectively. And so I want to take a moment now to do a poll, and I hope that you'll stick it out and just answer a few quick questions for us and let us know how you feel about the webinar you saw today and what topics you'd be interested in the future. And I know some of you, in entering your questions and comments, were looking for resources for additional information. So I want to encourage you to visit the End-Use website. And again, you'll be able to get access through that website, our main website, enduse.org, to data for all 50 states and the District of Columbia, which we've just posted. You can also see information from Jill's lab and other sources as well. And another source that may be of use is NIFLS, which is the National Forensic Laboratory Information System, which is also maintained by DEA, although a different division from where Jill is housed. And they recently set up a resource library where they have access to all of their reports and a number of different kinds of maps and things that they've been starting to produce as well. So I'm sure that you will find that information useful. And of course, I also encourage all of you, or if you are not already a part of our network, to join us there, because we release a lot of information, like the reports and announcements we get through NMS Labs, for example, on the network. And so you can join us there. The URL is network.enduse.org, and it's quick and easy to set up an account if you don't have one. And if you have any questions about how to do it, just let us know and we'll be happy to walk you through it. So it looks like things are slowing down a little bit here with the poll. So again, I thank you all for joining us today and for doing the poll for us. And I'll just give you a few more seconds in case there's a few more of you who would like to jump in and give us some feedback. And you're also always welcome to email us at enduse@umd.edu. We're always happy to hear from you, help you look for resources, or just share ideas and suggestions. Okay, well, I think we're coming close to the end of our time here. We did keep it to an hour, and so keep an eye out for the slides and the recording on our website, which one last time is www.enduse.org. And thanks again for joining us, and we look forward to seeing you all again next time.